Alrighty, everybody. I just got the okay to start our planetarium show, so I want to put away our space trivia questions for now because now we're going to be heading into the unknown. Ooh. And once again, folks, welcome to the Morrison Planetarium. Really quickly, I just want to introduce myself real quick. My name is Christian. I'm going to be your planetarium presenter. And just a heads up, folks, I'm not a person or a spooky voice coming out of the walls. I'm actually a person, and I'm standing right behind you. Hey, how's it going, everybody? Don't hurt your necks. Look forward into the dome before you. That's where the whole show is going to be. Everything that you see in purple lighting is going to be one enormous screen, thanks to the help of 6 different projectors hiding throughout our planetarium dome, which is going to give us that very immersive experience. And just to let you know, folks, we're going to be doing one of my personal favorite planetarium shows to do here, which is called Tour of the Universe. Essentially, what that means is that we're going to be starting off pretty close to planet Earth, and we're going to zoom all the way out to the very edge of the known universe. Hopefully, by the end of the show, you won't have an existential crisis of where we are in the universe. Just got to prepare you. We are very small in the grand scheme of things. And before we get started, I got to go over some quick house rules just so that we're all on the same page. We can have a great experience inside the planetarium. First off, there's no food or drinks allowed inside just because we want to make sure that everybody wears their mask while they're in the planetarium. So, again, no food or drinks allowed in. And not only that, we also want to make sure that the theater stays nice and clean for all of our future guests. Also, with keeping with cleanliness, we also want to make sure that there are no feetsies on the seatsies because, again, we want to make sure the seats stay nice and clean. And also, folks, if you happen to have any of these 21st century gadgets like cell phones or smartwatches, tablets, anything that produces bright white light, now is the perfect time to turn them off, deactivate them, put them away for the next 30 minutes. These devices produce really bright white light that can be very distracting for the folks sitting behind you and also for yourself as well. And I kind of just mentioned this right now, but again, folks, please wear your mask while you're inside the planetarium dome. Looks like there's about 50 of us, and again, we're going to be in here for 30 minutes, so make sure to wear your mask at all times, even during the dark portions of the programming. And folks, if you need to leave the planetarium for any reason, you're more than welcome to do so. All we ask is that you make your way up the stairs. That's where the exits are going to be before, during, and after the show. So when in doubt, always make your way up the stairs, not down. And lastly, folks, this show can be very immersive. If at any point during the show you start to feel overwhelmed, you start to experience motion sensitivity, there's a really quick and easy way to ground yourself. All you got to do is close your eyes, take a few big deep breaths. Your brain will remember that you're sitting in a planetarium in San Francisco and not hurtling through space, at least not more than the usual. Hee hee hee. But we'll be getting started in just a moment or so, folks. Alrighty, folks. Looks like we are ready to go. So let's get started with our tour of the universe. Alrighty, folks. As I mentioned, we're going to be starting off pretty close to planet Earth. We're hovering just about above Earth right now. You can see the atmosphere and the curvature of the Earth just below where we're at. And a lot of people tend to think that what we're looking at right now is a satellite. But what we're looking at, folks, is something called the International Space Station, or what we like to call the ISS for short. Now, the International Space Station is an amazing feat of human engineering, in my opinion. Pretty much, this is a research facility that's orbiting around planet Earth. So they conduct all sorts of different types of experiments up here that you're not normally able to do on Earth. And also, again, this is a collaboration between many nations across planet Earth. We have NASA, the European Space Agency, the Japanese Space Agency, Russian Space Agency, just to name a few. So, quite a lot of folks put a lot of work into this. But again, the different types of experiments that they conduct up here are like things like how do plants grow out in a low gravitational environment, like out here in space? What happens when you try to drink a glass of water? Is it the same on Earth as is out here in space? And what happens when you turn on a lighter or a match? Does fire behave the same way? So these are some of the different types of experiments that they'll conduct up here at the International Space Station. And it looks like we kind of lost ourselves in the tilt, so I'm just going to reorient ourselves real quick. And folks, right now it looks like the International Space Station is enormous, especially on our screens, but it's only about the size of an American football field, so not too big. That's about the size of the Academy of Sciences, which we're at right now, from one garden to the next. And folks, this thing is going incredibly fast. The International Space Station goes a whopping 17,000 miles per hour, where it orbits once around the Earth every 90 minutes, where it experiences 16 sunrises and 16 sunsets a day. How romantic. And just to let you know, folks, this is as far as we put humans into space nowadays because traveling into space gets quite costly quite rapidly. First off, you need to find yourself a rocket ship or build yourself a rocket ship, and then you need to get your hands on a bunch of rocket fuel. And you're going to need a lot of it because you need to get that rocket fuel and your rocket ship off the planet Earth, which takes a lot of fuel. And then not only that, you're also going to need a lot of bring all the food, all the water, and all the air you're going to be breathing while you're out here in space. So the bill starts to get really costly quite rapidly. Ooh, almost forgot, folks. The International Space Station looks really far away from planet Earth, but it's not too far away. It's only about 250 miles above the surface of the Earth. So 250 miles, that's like going from San Francisco to Santa Barbara, a nice little road trip to get away with the family for the weekend. But we're going to start to slowly pull away from the International Space Station, and we're going to see it disappear compared to our planet. And before we lose sight of the International Space Station, I want to bring up a marker so we can keep track of it as we continue zooming out. So there's the path of the International Space Station. And just to let you know, folks, the space program that we're using right here in the planetarium is something that you can technically go home and download on your computers. The program I'm using here is something called OpenSpace. So if you go to Google and just type in openspaceproject.com, you'll be able to find the software that you can download at home. But just to let you know, this program is in its beta phase, which means it's not completely finished. We might experience a few bugs and glitches here and there. And if we do, I'll let you know. And also, if you do download this program, I do highly recommend having a really good computer or a relatively new one. OpenSpace pulls a lot of information and processing information. So if you have a gaming computer, definitely go ahead and download this. If you're not really good with downloading programs, there's also a really good alternative to flying around and learning about space. If you just head over to NASA's Eyes, just like your eyeballs, NASA's Eyes don't have to download anything, and you're still able to fly around in the solar system. So a couple of programs that you can check out at home as well. But let's make our way over to our nearest natural neighbor to us in space, the moon. So now we're going to be making our way over to the moon, folks, not too far away from us here on Earth. And it looks like we have about half a moon right now. So I have some special abilities here in the planetarium. I'm going to turn off the nighttime on the moon because we're able to do that here so we can get a better look at it. And just to let you know, folks, we humans have been to the moon before. That was between 1969 and 1972, thanks to NASA's 6 Apollo space missions that brought a total of 12 incredibly lucky guys to walk on the surface of the moon. They got to conduct science experiments, and also they got to play golf up here as well. But again, that was the last time was in 1972, so a little more than 50 years ago or so. But don't worry, folks, NASA has a new space mission that's going to be launching relatively soon in the next few years or so. This new space mission is called Artemis. And Artemis is going to be sending the first woman to the moon. But not only that, they're also going to be sending the first person of color to the moon. But not only that, they're also going to be setting up the first lunar base. Essentially, NASA's new mission, Artemis, their main goal is to send humans to Mars. But before we send humans all the way to Mars, we need to figure out how exactly we humans are going to live on another celestial body. So the moon is only about a 3-day rocket trip away from us. So this is something that we can figure out and try to learn how to live out here in space. But what's also really cool is that this Artemis program is also going to be having its own International Space Station and orbiter that's going to be orbiting around the moon the entire time. So as they set up different bases on different locations around the moon, if anything was to go wrong, they're able to launch away from the moon and head back to that orbiter. And that thing is going to be called Lunar Gateway. So really cool stuff. So look out for any news about Artemis coming in the near future. And here on Earth, folks, when we look up at the moon, it almost feels like sometimes you can reach out your arms and touch the moon. It feels so close, especially when it's close to the horizon. But the moon's relatively far away from us. It's about 240,000 miles away from the Earth. Whew, 240,000 miles, that's 250,000 miles. Now, for the adults in the room, you may have a car with that many miles on it, and if you take better care of your car than I do, you can even imagine driving to the moon if you drove for 4 months nonstop going 80 miles per hour. Although I wouldn't recommend it, the roads out here are poorly maintained. Hee hee hee. And from here on out, folks, we're going to need to use a more useful measuring stick because at this scale, using miles is kind of like using inches to describe the distances between cities. So astronomers use a more convenient measurement known as light speed. Now, light travels at a mind boggling speed of 187,000 miles per second. That's about 300,000 kilometers per second. So while it took the astronauts more than 3 days to reach the moon, traveling faster and farther than any human has done so or since, it only takes light 1.5 seconds to cross that distance at the speed of light. So really fast, only like a brief pause in conversation. But we're gonna leave the moon for now. So everybody say bye bye moon. We'll see you later. I love that part. And now, folks, we're going to be heading out to a much greater realm of our solar system because now we're going to watch the moon and the Earth and their orbits as they slowly recede. In fact, let's bring up the orbits of all the planets in our solar system so we can see where everything is. And on our journey, we're going to be traveling much faster than the speed of light. We're going to be traveling at the speed of the human imagination, thanks to the help of computer models like OpenSpace, showing us the most accurate images and information available. But now the nearest star to us, the sun, comes into view, and the sun is about 93 million miles away from us here on Earth. 93 million miles away. In terms of light speed, that's only about 8.5 minutes at the speed of light. Now, that's also a really cool concept to keep in mind as well, folks. So, let's say, for example, the sun was to turn off all of a sudden. We wouldn't know about it here on Earth for about 8.5 minutes because that last bit of sunlight that got emitted from the sun takes that long to travel that 93 million miles away from us. And then all of a sudden, we get that last bit of sunlight, and then on Earth, it would be nighttime for everyone. Now, this is a really cool concept to keep in mind because this works really well for really far away objects. For example, let's say we're looking at a star that's 60 light years away from us. Well, we're looking at that star as it looked like 60 years ago because it took that light that long to travel that really far distance. So when you're looking at really far away objects out in space, it's kind of like looking back in time in a sense, which is pretty cool. And now that we have a nice bird's eye view of our solar system, let's name some of the planets that we have in our solar system really quickly. So, right in the middle, we have our star, the sun, not a planet, which is right there. And then the closest planet to the sun, we have Mercury, and then we have Venus and Earth. That's us. And then we also have Mars. So, these are the rocky terrestrial planets. These are places we can actually land a spacecraft on. And then beyond Mars, we have this really cool thing called the main asteroid belt. And if we were to highlight all the asteroids in the asteroid belt, it would look something like this. There we go. So again, this is what it would look like if we were to highlight all those asteroids in the asteroid belt. But then beyond the asteroid belt, we have the really big planets. We have the gas giants. We have the Jovians. We've got Jupiter and Saturn. And then past those, we have the icy giant planets. We've got Uranus, the funny one, and Neptune. And then we can also add Pluto as well, because I know a lot of folks love Pluto. I do love Pluto as well. But just to let you know, Pluto is no longer considered a planet. It got demoted to a dwarf planet in the year 2006. And a lot of people tend to ask me, hey, Christian, why did Pluto get kicked out of the Planet Club? I love Pluto. I learned about Pluto. Viva la Pluto. Well, you see, folks, we humans got really smart, or at least we started learning a lot more about our solar system, specifically the region of our solar system beyond the orbit of Neptune. And we found more than 400 objects out here in this new area called the Kuiper Belt. And you're probably wondering to yourself, what's the Kuiper Belt? I've never heard of that. Well, the Kuiper Belt's going to be all this stuff. Yeah, so we found more than 400 objects out here. Some of them were bigger than Pluto, so we couldn't call all this stuff planets. There was just way too many of them. So all the astronomers across planet Earth had a great big meeting, had to figure out what exactly you need to be to be considered a planet. And one of the criteria that Pluto failed is that you need to be so big and so massive that you need to push all the other stuff out of your orbital path. And unfortunately for Pluto, it didn't pass that one criteria because Pluto orbits around its own moon, Charon. So this is one of the reasons why Pluto got kicked out of the Planet Club and is now considered a dwarf planet. But don't worry, folks. There's quite a few dwarf planets out here in the Kuiper Belt region. We've got Make, and Haumea, just to name a few. And of course, we have Ceres in the main asteroid belt as well. Oh, I also forgot to mention that the Kuiper Belt is essentially a second asteroid belt. You'll mostly find icy asteroids and icy comets out here. But I want to put away the Kuiper Belt away because that's just a whole lot to look at. And really quickly, I want to add some of the spacecrafts that we sent out in the 1970s to explore our solar system so we can learn more about it. And here they are. There we go. So we have our trajectories here. We have Pioneer 10, Pioneer 11, Voyager 1, and Voyager 2. And the latest of them all, we have New Horizons, which did a quick flyby of Pluto, which we can see a nice intersection right over here. They in New Horizons did a flyby in 2015, gave us some amazing high definition images of Pluto. Before, our photos of Pluto were pretty much pixelated dots from that we gathered here on Earth, but we were able to learn a whole lot of new information about this dwarf planet out here in the outer part of our solar system. But we're going to leave our solar system behind, folks, because now we're going to be heading into interstellar space, the space between the stars. Distance now becomes so immense, it's going to take us over 4 years at the speed of light just to reach the next star system to us, the Alpha Centauri system. And if my calculations are correct, Alpha Centauri is going to be this one right over here on the right hand side. We have our solar system right in the middle. Alpha Centauri, 4 years at the speed of light to reach the next star system to us. Now, if we got in a rocket ship, our today rockets, and try to travel all the way over to the next star system to us, it's going to take us 18,000 years to make that trip. Woo, that is a very, very, very long road trip. But, folks, we're going to stop and consider whether humanity has made its presence known beyond our own solar system, because now we're going to be heading inside something called the radiosphere. And again, we are now inside the radiosphere, and this represents the current limits of the most distant radio signals humanity has ever broadcasted, or rather leaked into space. And it extends about 90 light years in all directions, emitting out from the Earth. And this first began in the early 1930s with strong radio waves, early television, radar signal, and then later the detonation of atomic weapons. All these things are emitting electromagnetic radiation strong enough to escape the Earth's ionosphere. Now, humans were broadcasting well before that, but the earliest radio was not quite powerful enough to escape the Earth. Since all these signals are electromagnetic, they travel at the speed of light, so this is kind of like humanity's electromagnetic footprint in the universe. And of course, the radiosphere is always expanding at 1 light year per year, so is anybody out there listening? And folks, I'm going to be bringing up some markers onto the screen. These markers represent some of the many thousands of stars astronomers have discovered over the last 22 years, which has at least one or more planets orbiting around them. We call these planets exoplanets, and we're looking for any of them that are Earth like with conditions suitable for life as we know it. So far to date, we found more than 4,000 exoplanets in the nearby vicinity to us. And we have new space-based telescopes where their whole purpose is to find as many exoplanets as possible. So that 4,000 number is going to be increasing as the years continue. And not only that, we're getting really good at finding exoplanets. If you look on the right over here on the right-hand side of the screen, you can see a dense number of exoplanet markers right over there. We're able to let our space-based telescopes just to look in one direction, and we found a whole heap of exoplanets just in that direction. So it's just a matter of time as we continue scanning more of the night sky. But figuring out if any of these exoplanets have life suitable for humans like us, well, that's a whole different question. Um, our technology is not yet able to answer that question, but new generations of astronomical instruments are devoted for that search and in the process of being built right now. But the important point here is quite a few of these planetary systems are within that 90 light year limit of our radiosphere and could have potentially received our signals. However, since radio waves travel at the speed of light, if there is anybody that's out there able to listen in and answer back, the communication delays between hellos could be decades in time. For example, let's say we're inside our radiosphere, we live on the far left planetary system right over here. Let's say that's us. We find an alien civilization on the other side, on, say, this one right here. We shoot them a text message. Hi. Takes 90 years to get to them. They listen in, answer back. Another 90 years to send their message. So that is a 180-year conversation in the making. Woo. And I can barely wait for a text message from my friend. But of course, folks, planetary systems beyond the radiosphere, more than 90 light years away, have not heard from us yet, but eventually they will, as the radiosphere is always growing, but it becomes weaker as it does. And for now, folks, I'm going to put away our exoplanet markers, but I'm going to leave our radiosphere up there. As huge as our radio influence is on the nearby space to us, it is nothing compared to the structure of our Milky Way galaxy. So let's see if you can still see our radiosphere as we zoom all the way out. Alrighty, folks. So now we're looking down at our Milky Way galaxy. Can anybody see their house from here? And just to let you know, folks, the Milky Way galaxy is incredibly large. If you wanted to go from one side to the other side of our Milky Way galaxy, it's going to take you 130,000 years at the speed of light. Whew, now that is a long road trip. But not only that, our Milky Way is so huge, we estimate that there's at least 300 billion stars in our galaxy. If our recent discovery of so many exoplanets just within our small neighborhood, within this vast star city, is any indication, there could be billions of planets and potentially millions of Earth like planets throughout our single galaxy. And before we leave our Milky Way galaxy, I do want to stress the shape of it. When we look at the Milky Way galaxy from a sideways perspective, you notice that we live in a flat spiral disk. Now, just keep this in mind, folks. This will come important in just a little bit. When astronomers and scientists want to learn about the universe, it's so much easier for them to point their telescopes and equipment galactically north and galactically south instead of looking through the plane of the Milky Way galaxy, which has planets, nebula, gas, debris, rocks, things that obscure their view of the universe. So just keep that in mind. We point our telescopes and equipment galactically north and galactically south. But let's continue zooming out. And just to let you know, folks, the Milky Way is only one of many hundreds of billions of galaxies that comprise the known universe. And in this giant leap, we're now seeing a view where each point of light represents not a star, but rather the location of an individual galaxy, each galaxy containing hundreds of billions, perhaps trillions of stars. Now, we live in our local galaxy group, which contains about 30 galaxies, large and small. Also includes the nearest spiral to us, the Andromeda Galaxy, only 2 million light years away, just next door, and we're heading right for it. We're going to get to know it pretty intimately in about 5 billion years, so mark your calendars. And folks, as our picture expands, you're going to start to notice that galaxies are not evenly distributed throughout space. Instead, galaxies like to clump together in large clusters or great regions or voids where there's very few galaxies. So just keep that in mind as well. Galaxies like to hang out in large clusters that we can see on the bottom left right over here. That's one galaxy cluster. And then you can also look towards the top. You'll see very few galaxies where you don't see any galaxies hanging out. It's kind of like a void in space. That will also come up a little bit in the show. But folks, we've zoomed out so far now that the picture that we're looking at right now represents the 30,000 closest galaxies to us in space over 300 million light years across. We've got to give thanks to an amazing fellow by the name of Dr. Brant Tully, who worked at the University of Hawaii, who compiled this amazing representation of this galactic map, thanks to the work of other dozens of astronomers working alongside him over decades of time. So big shout out to Brent Tully. I love flying through this galactic map that he made for us. But folks, now we have automated systems that are mapping to the most distant galaxies. So now we're about to view the large scale structure of the universe. And remember, folks, every single point of light that you're seeing is not a star. That's an individual galaxy. Ooh. And just to let you know, folks, the universe is not shaped like a bow tie or a butterfly. Remember when I just mentioned that we live in a flat spiral disk of our Milky Way? Well, if we were to line up our Milky Way galaxy plane, it would line up just right in the middle, just like this. And again, we point our telescopes galactically north and south instead of looking through that gas and debris. Now, astronomers still want to make sure that there was galaxies through the plane of our Milky Way, and you can see a nice purple survey of galaxies right over here. But you're going to notice that the telescopes and equipment couldn't record galaxies as far compared to looking galactically north and south. So, as our technology gets better over the years, we'll eventually be able to fill in these dark gaps and map all those galaxies through the plane of our Milky Way galaxy. So, it's only a matter of time. But folks, we're going to continue moving out because we still have a little ways to go to the very edge of the known universe. And now we're going to be looking at very, very, very distant, very young galaxies. These orange dots over here, which are known as the quasars. Now, quasars are short for quasi-stellar radio sources, and these blazing objects are all billions of light years away. So now we're looking so far back in the depth of time and space that the most distant quasars represent the universe at a much earlier age. We're nearing the very beginning of galaxy formation. In other words, with the quasars, we're viewing a sort of awkward, gawky teenage version of the universe. And before there was a teenager, there was a baby. So now we're going to press to a time before quasars, before planets, stars, and even galaxies began to form. So, folks, we are now about to approach the very edge of the known universe. And here we are. So, folks, what we're looking at now is something called the cosmic microwave background image, or the CMB image for short. Now, all evidence indicates that the universe that we live in is about 13.8 billion years old, and this is data compiled by Planck and other radio telescopes. And the picture that we're looking at is a very baby version of the universe, only 380,000 years after the Big Bang occurred, where space and time began. And what we're looking at is not a typical photo, but a temperature density image, where the light echoes of the Big Bang are color coded, with lighter areas corresponding to the hottest, least dense regions, and the darker areas, the coolest, densest regions. These fluctuations in temperature and density are extremely, extremely tiny. They vary no more than 1 part per 100,000, so very minute differences. But eventually, they gave rise to the large scale structure of the universe that we saw moments ago, that clumping and clustering of galaxies everywhere. Figuring out just how this happened is one of the larger challenges for cosmological research today. Though our view here is at the outer edge of the known universe, the earliest light visible to us, that radiation actually persists all around us. It permeates the universe, stretching and cooling as the universe expands over billions of years of time. But folks, we have gone as far back as the law of physics can physically allow us, so we only have one direction left to go, back home. So let's find a nice entry point through all these quasars and galaxies and make our return trip back to planet Earth. Alrighty, folks, y'all ready for this? Yeah, all right, let's go. Alrighty, folks, we're crossing the expanse of 13 billion light years, and we present you with this view of our universe and the latest in cosmological and astronomical information. We're covering eons and observing objects billions of light years apart. Now, we live in a golden age of astronomy. New generations of telescopes and spacecrafts are extending the reaches of our eyes, preparing for the eventual race between the advancement of technology and the accelerating expansion of the universe. With that thought, folks, I want to remind you all that astronomy is for everyone. You don't need to be a rocket scientist to enjoy the beauties and wonders of our universe. All you need is the night sky, and if you can, get away from the lights of our cities and look up. Even a good pair of binoculars makes for a decent first telescope, and there's astronomy clubs all around the world that invite people just like you to look through their telescopes and peer into the great beyond, allowing you to partake in the wonders that our universe has to offer. Now, astronomy as a hobby can offer an endless supply of satisfaction, and I do hope you'll join us, those who dream amongst the stars. But it looks like we're making our way back into our Milky Way galaxy, heading straight into our local galaxy group, and heading straight to that radiosphere. And of course, we are making our way back into our star system. And passing the Kuiper Belt region, the orbit of Pluto, all those spacecrafts that we sent out in the 1970s to explore our solar system. And we're making our way to the third rock from the sun, our homeworld, our pale little blue dot, the only place humans have called home, at least for now. And as we make our final approach back to planet Earth, folks, this is going to be the end of our Tour of the Universe show. I want to thank y'all for stopping by and watching it with me today. I hope you did enjoy it. But hey, look at that. We made it back to Earth safe and sound. And that's all I have for you today, folks. Thanks for stopping by.